Beneath the tar, on the valley floor, rare pools of water teem with life. Freshwater fish. Only 3 species survive in the Al Hajar Mountains, and this one is the Oman Garra. They endure only in isolated permanent pools of the wadi. These tiny fish get by scraping algae and any other detritus from the rock walls of their watery prison. Their survival depends on much-needed rainfall to replenish their shrinking refuge. But rain is unpredictable in Arabia. Some years it does not rain at all. Then some pools will dry up, and the fish in those will die. 80% of the water that falls in the mountains will evaporate. The rest quickly runs off the hard ground and into cracks in the rocks. Rain here in the Al Hajar Mountains is erratic and unreliable. A mere 6 inches falls each year, and it comes in only a few short, heavy bursts. The rain runs off the mountains, building momentum as it descends to the valley floor. Light rain can quickly turn tranquil pools into rapids. While toads stay clear, the rushing water has the opposite effect on the garra fish. This is the opportunity they've been waiting for. They have a mysterious, instinctive drive to always explore upstream, driven by the need to expand their territory. They take whatever opportunity they can to forge into the current. This is how the species can recolonize areas where the previous inhabitants have perished. But this is not just fish swimming upriver. These fish undertake an epic climb. Their sucker mouths, which usually scrape algae from the rocks, become anchors, securing them against the fast-flowing water. A group inches its way up the rocks. The fish must stay within the splash zone in order to breathe, but stay out of the main flow to avoid being washed back downstream. The fish can travel up to 9 feet up sheer rock faces. For those that make it into new pools, there are fresh possibilities, food, and a new territory to colonize. The stress of the journey is also thought to trigger their spawning behavior, to make sure every new pool is quickly populated by the pioneers. Their sticky eggs will settle in the gravel to stop them washing back downstream.
While the saltwater crocodile relies on brute strength to capture its prey, another more diminutive hunter has evolved a highly skilled approach. The archerfish. Omnivorous, opportunistic, and an expert marksman. It will consume anything floating in the water, but has developed an extraordinary skill for hunting prey far beyond their aquatic domain. A master of physics, the archerfish can make lightning-quick calculations to perfect its aim and dislodge prey. A garden orb weaver spider has selected a branch to form the foundation of its web. Little does it know, the new property is well within the fish's accurate 6-foot range. When eyeing its quarry, the archer must compensate for refraction, the bending of light as it passes from air to water. Viewed from below, the target isn't exactly where it seems. Despite the accurate shot, the spider manages to maintain its grip on the branch. Compressing its tongue against a groove in its mouth, the fish creates a tube to funnel the water. A special cover over the gills rapidly snaps shut, forcing the water through the tube. Once again, the spider clings on. This archer must also account for the curved trajectory of the water jet. Letting gravity bend the shot toward the target. Success.
To all the different kinds of bugs that live here, the forest is a giant buffet. This giant grasshopper is a herbivore. It has the basic insect toolkit, 3 sets of mouthparts. It uses sideways slicing, jagged mandibles, like scissors, to cut up leaves. The other 2 sets carry jointed palps that taste the food before the grasshopper bites into it. This multi-blade Swiss Army knife of tools evolved from primitive legs, and with a few minor modifications, can be used to tackle many different items on the insect menu. This African ground beetle is a carnivore. It hunts on the forest floor, but it won't be a high-speed chase. It hunts slugs. These defenseless mollusks seem to just wait to get captured. The beetle's mandibles have pointed tips, more like curved daggers than scissors. Perfect for piercing the gelatinous slug and dragging it off. The mandibles also serve as steak knives. Below the pointed tips, sharp blades chop up slug meat into bite-sized pieces. Covered in slime, there's no elegant way to eat a slug. But the little African ground beetle is no slob. Keeping its mouthparts and legs clean is vital to its survival. So, after it finishes a meal, it finds a napkin to wipe itself clean. This bit of leaf will do nicely. Grasshoppers and beetles use the insect equivalent of knives and forks to cut and then chew their food. This stealthy assassin bug prefers to stab and suck. All 3 sets of mouthparts are moulded into a long, sharp beak, or rostrum, strong enough to puncture the armour of its prey. In this case, a wandering cockroach. The beak is hollow. When it pierces the roach's tough exoskeleton, it injects a deadly, fast-acting poison which dissolves the prey from the inside. Then, with straw already inserted, the assassin bug slurps up the gourmet cockroach soup. This South African rock scorpion isn't an insect, it's an arachnid, so it starts with a different basic toolkit. One set of primitive legs has been transformed into giant claws called pedipalps, evolved to grab and hold prey using brute strength. Though it's a bit of overkill on a little woodlouse. Scorpions don't have mandibles. Instead, another much smaller pair of claws, the chelicerae, reinforced with heavy metals for toughness, tear and shred its meal, before passing morsels into its mouth, hidden from view. All arthropod mouthparts started out as primitive legs, but evolution has transformed those basic jointed limbs into different structures, from claws to straws. It's just one of the reasons for their incredible success.